Hello my dear kiddos, how are you? Welcome to the ultimate recap of the chapter Binomial Theorem on the one and only PW Gulf channel. How are you? Hope you're doing well. Meeting after a long time. Yes. So Binomial Theorem, quite an interesting chapter because yes, in this chapter we learn things like how do formulas actually come? How formulas actually come into picture. The formulas that you have seen, a plus b the whole square, a plus b the whole cube, etc. Right? Okay, so the word binomial, if you try to divide it into two parts, it is made up of bi and nomial. Bi means two and nomial means term. So there are two terms. If there are two terms in the expansion, it is called as binomial. We are going to learn about expansion of such two terms, right? That means if you all know, if a plus b raised to 0, it is 1. A plus b raised to 1 is a plus b itself. A plus b the whole square. I think हर एक बच्चे को इसका आंसर जरूर आता है. It's a square plus 2ab plus b square. Similarly, yes, with a little bit of efforts, we have also by hearted a plus b the whole cube. Am I right? But what if I ask you about a plus b the whole raised to 4 and a plus b the whole raised to 5 and a plus b the whole raised to 6 and so on and so forth? That is expansion of two terms, a plus b the whole raised to n. N can be any natural number or 0 also included. That means n can be any whole number. What is the expansion of this particular term? This is what binomial theorem is all about. Okay, so to know about it, let us understand a little bit of theory. Let us understand how this formula comes into picture. All right, bacho. There was a scientist, there was a mathematician called as Pascal, and Pascal, he did some brilliant job in giving the theorem, in giving the expansion formula. What he did, just now I told you about this. Now, if at all, a plus b the whole raised to 4, I ask you, with some more efforts, you would have done a plus b the whole square into a plus b the whole square. And by, a plus b the whole square, then multiply both the brackets, a little more efforts. If I ask a plus b the whole raised to 5, you would have done a plus b the whole cube into a plus b the whole square, then expand like properly. But then more efforts. Is there a shorter way? Is there an easier way? Yes, observation. What Pascal did was observation. He observed that if the power is 0, there is only one term. If the power is 1, 2 terms. Power is 2, 3 terms. Power is 3, 4 terms. Power is 4, 5 terms. If power is 5, then you can guess there will be 6 terms. So total number of terms is always one more. Total number of terms. If the power is n, there is always one extra term than the power, right? One extra term than the power. That's total number of terms. Second observation. The power of a. Look at a. Look at a. The power of a is 1 here and here nothing. A is not there means 0. Power of a 2, then 1 and nothing means 0. 2, 1, 0. Then 3, 2, 1 and nothing means 0. 3, 2, 1, 0. Similarly 4, 3, 2, 1 and nothing means 0. So the power of a is starting from n. N is your index. N is the index. It starts from n and reduces to 0. It is decreasing. Power of a is decreasing. Decreasing from n to 0. And what about b? Yes, here nothing means b raised to 0. So 0, then b raised to 1. Nothing means b raised to 0, b raised to 1, b raised to 2. B raised to 0, b raised to 1, b raised to 2, b raised to 3. B raised to 0, b raised to 1, b raised to 2, b raised to 3, b raised to 4. Can you see the power of b is increasing from 0 to n? That's your third observation. And one last observation मेरे बच्चों, एक और observation, सुंदर सा observation हमने करना है, that the sum of powers of A and B will be equal to n. 1 plus 0, 1, 1 plus 0, 1, 2 plus 0, 2, 1 plus 1, 2, 2 plus 0, 2, 3 plus 0, 3, 2 plus 1, 3, 1 plus 2, 3, 3 plus 0, 3, 4 plus 0, 4, 3 plus 1, 4, 2 plus 2, 4, 1 plus 3, 4, 4 plus 0, 4. So the sum of powers of A and B is always equal to sum of index of each term. If I talk about each term, sum of index of each term is always equal to n. Right, boss? These are the 4 observations made by Pascal. Okay. Next set of observations. Now, when you put those constants, when you put those coefficients, now let us call this as coefficients. 1, your coefficient is 1, 1, your 1, 2, 1, then 1, 3, 3, 1, 1, 4, 6, 4, 1. These are nothing but coefficients. Now, if I put these coefficients, for 1, coefficient is 1, 1. For 2, it is 1, 2, 1. 3, it is 1, 3, 3, 1. Right. 1, 1, 2, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. This is nothing but your coefficient and this is index. Notice this coefficient. There's a beautiful thing happening in this coefficient. Okay, sorry. Can you see that this 1 plus 2 gives me 3? 2 plus 1 gives me 3. Similarly, 1 plus 3 will give me 4. 3 plus 3 will give me 6. 3 plus 1, 4. So how am I getting the next coefficient? Starting and ending is always 1. Starting ending is always 1. First and last is 1. But how to get in between coefficients? By adding the above 2. 1 plus 1, 2. So this is called as Pascal's triangle. How do we get the next coefficient? By adding a Pascal's triangle. For example, if I want for 5. So starting and ending will be 1. Then you add this 4 plus 1, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1 again 10. So these are the coefficients for index 5. If I want the coefficient for index 6, I'll again put starting ending 1 and then 6, 15, 20, 20, 10 and 1. 10 कैसे आया? 4 plus 1, 5 होगा इधर. यहाँ पे this is 5, right? Okay. 5 plus 1, 5 and then here 1. Starting ending 1 and I'm getting all the coefficients. Now if you know the coefficients, then you can make a formula. Obviously you all can make a formula of a plus b the whole raised to 5 very easily. कैसे भाई साहब? A plus b the whole raised to 5. 1, 5, 10, 10, 5, 1. Coefficients written. Next, power of a should keep on decreasing. Decreasing. Start from 5, 4, 3, 2, 1, 0. And power of b should keep on decreasing. Increasing from 0, 1, 2. I missed one term here. Not a pseudo. What was this? 4, 3, 2, 1. Right. So your B0, B1, B2, B3, B4 and B5. And just put plus sign in between it. That's your formula for a plus b the whole raised to 5. If you want the formula for a plus b the whole raised to 6, put down the coefficients. Right? Write down the coefficients and keep on decreasing the power of a, increasing the power of b. So now if I want the formula for a plus b raised to 12. For finding a plus b raised to 12, I should know the row of 11. I should know the coefficients of 11. So I can add and get the coefficients of 12. We need coefficients of index 11. है ना? That means after 6, you'll have to write 7, 8, 9, 10, 11, and that's how you will get 12, which is again very lengthy. So he did one more super fantastical observation, which is, this is called as Pascal's triangle, you know, adding up the coefficient. 1, 2 will give us 3 and so on. Similarly, 1 plus, like that. Pascal's triangle. The fantastical observation he did was, he introduced combinations. Now you all know a very simple funda, NC0 is equal to NCN equal to 1. And NCR is equal to NCN minus R. The property. That is his fantastical observation, guys. Please note. The 1 can be written as 0C0. 1 can be written as 1C0, 1C1. 1 and 1, 2C0, 2C2, because 2C0, 2C2 is 1. 2, here, can you see 2? In place of the coefficient 2, we can write 2C1. Similarly, in place of coefficient 3, 3C1 and 3C2, because both will be equal. In place of 4, 4C1, then 6, 4C2, 4, 4C3, and 1, 4C4. So there's a pattern. Now if I want to write for 6, I can write 6C0, 6C1, 6C2, 6C3, 6C4, 6C5 and 6C6. In general, if I want to write for 12, if I want to write for the index 12, I can write 12C0, 12C1, 12C2, 12C3 and so on till 12C12. So now we know the coefficients without knowing its previous row. Isn't that beautiful? Without knowing its previous row coefficients, we can now find out the coefficient of any power. If the power is 100, yes, we know 100C0, 100C1, 100C2 and so on. So directly coefficients, no need of forming those triangles by adding them. Right. So this is your formula for NCR combination formula, n factorial upon r factorial n minus r the whole factorial, and these are nothing but binomial coefficients. The binomial coefficients is now your NCR. So what is exactly the binomial theorem and what are the variations of binomial theorem? I'll tell you and then we'll move on to the questions. Next part will be your general and middle terms. So few questions on binomial expansion and then general and middle terms. Alrighties, but show the formula for binomial expansion of x plus y raised to n is equal to, you start from NC0, then first term raised to n minus 0, second term raised to this 0. NC1, first term raised to n minus 1, second term raised to 1. NC2, first term raised to subtraction of these two, second term raised to the base. NC3, x raised to n minus 3 and y raised to 3, and so on. You go on doing this till NCN, x raised to n minus n and y raised to n. Now n minus n is 0, so you can write 0 also. Correct. In short, if I have to cut this binomial theorem in short, I can write x plus y the whole raised to n is equal to summation of NCR, r running from, r starts from 0 to n, first term raised to subtraction of these two and second term raised to this term in the power. Check out. That's what your binomial theorem is. Now little bit of variations. That's the first formula for the day. If I change this plus y to minus y, what happens is x minus y the whole raised to n formula, alternate plus minus, alternate plus minus. That means all the odd terms will have a minus sign now. NC1, x raised to n minus 1, y raised to 1. NC2, x raised to n minus 2, y raised to 2. NC3, x raised to n minus 3, y raised to 3. And so on, you will go on doing till your last term. Alrighties? Very good. Third variation is, instead of x, I am taking 1 and instead of y, I am taking x. So replace, in each of the term, you replace x with 1. 1 raised to anything. 1 raised to anything, you all know. This x 1 raised to n, 1 raised to n minus 1, 1, this is 1 only. So you'll get a very nice formula. nc0 plus nc1 x plus nc2 x square plus nc3 x cube plus nc4 x raised to 4 and so on till ncn x. The second term is only written, second term is. And fourth variation is when in the second formula take x as 1 and y as x. If you take x as 1 and y as x, check nc0 minus nc1 x plus nc2 x square minus nc3 x cube plus nc4 x raised to 4 and so on. Here, by the way, there will be and so on till ncn x raised to n. Are you able to understand? Please remember, whenever there is minus sign, the only difference is this 1, 3, 5, they will have minus sign. 0, 2, 4, 0, 2, 4, they will have plus signs. Alright, great, good. So questions try karte hain, expand this binomial theorem by binomial theorem. First term, second term is given to us. Therefore, x square plus 3 by x the whole raised to 4 will be equal to 4c0, first term raised to 4 minus 0 and second term raised to this term 0. Then 4c1, first term raised to 4 minus 1, 3, second term raised to 1. 4c2, first term raised to 4 minus 2, 2, second term raised to 2. 4c3, first term raised to 4 minus 3, 1, second term raised to 3. And lastly, 4c4, first term raised to 4 minus 4, 0, second term raised to 4. Check out, simplify. Yes, you don't have to leave it here. You have to put the values and simplify. 4c0, nc0 in general is 1. And please observe, it's a palindrome in binomial. Whenever you will expand, first term, last term, same. Second term, second last term, same. Third term, third last term, same. Fourth and fourth last will be same. Coefficients I'm talking. 4c0, 4c4, 1. 4c1, 4c3, 4. 4c2, calculate, 6. So 1, I'll simply write this x raised to 8 and anything raised to 0 is 1. So this term 1. 4c1 is 4, x raised to 6 into 3 upon x. 4c2 is 6, x raised to 4, 3 square 9 upon x. 4c3 will be again 4, x square, 3 cube is 27 upon x. And 4c4 is 1, anything raised to 0, 1. 3 raised to 4. How much is 3 raised to 4, boss? 81 upon x raised. Something is cancelable, do that. Not, leave it. The final answer is x raised to 8, 4 3s are 12 times x raised to 5. 6 9s are 54 times x square. 27 into 4 will be how much? 50, 108 upon x plus 81 upon x raised to. That's the ultimate answer, expansion. No further simplification possibles, leave it. चलिए, compute 98 the whole raised to 5. ठीक है? Now 98 the whole raised to 5, can I write it as 100 minus 2 the whole raised to 5? You have to write the nearest known number to you. Nearest number which is known to you and which is easy to calculate. 100 is a number whose powers are easy to calculate. And use the formula. Which formula will you use? Ma'am, we will use the second formula, x minus y the whole raised to n. So start. 5c0, first term raised to 5 minus 0 is 5 and second term raised to 0, then minus 5c1, first term raised to 5 minus 1, 4, second term raised to 1, 5c2, first term raised to 5 minus 2, 3 and second term raised to 2, minus 5c3. Can you see alternate plus minus? Yup, that's what you have to do. 5c4 100 raised to 1 and 2 raised to 4, and finally 5C5, 100 raised to 0 and 2 raised to. Simplify a little. Big calculation. Once again, 5C0, 5C5 will be 1. 5C1, 5C4 will be 5. 5C2 and 5C3 will be same, and you can calculate here. Bachcho, NC2 in general is nothing but n minus 1 by 2. You can see, apply the formula. So 5C2 will be 5 into 4 by 2, 10. If 5C2 is not, 5C3 is same because 5 minus 2 is 3. 100, 1, 2, 1, 2. Okay, 1, 2, 3, 4, 5. 5C1 is 5 times into 2 times into 1, 2, 3, 4. 5C2 is what? 10. 10 times 1, 2, 3. And there is also into 2. Minus 10, 1, 2. 2 3s are 8. 5C4 is again 5 into 100 into 2 raised to 4, 16. And lastly, 5C5 is 1, 2 raised to 5, 32. Okay. Unit, tens, 100, 1000, 10,000, lakh, 10 lakh, crore, 10 crore. 1, 2, 1, 2, 3, 4. Right? 5 times you'll. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, do the calculations. Unit, tens, 100, 1000, 10,000, lakh, 10 lakh, crore, 10 crore, 100 crore, 1000 crore. It's like your 1000 crore. ठीक है. Thousand crore minus 5 twos are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. 2, 4, 5, 6, 7, 8, 9 zeros. Unit 1000, 10,000, 10 lakh, crore, 10 crore, 100 crores. This is your 100 crores plus 1, 2, 3, 4, 5, 6, 7. 2 crore. है ना, 7 zeros, 3, 4, 5, 6, 7. 4, 5, 6, 7, right? And then 8. 1, 2, 3, 4, 5 zeros. 1, 2, 3, 5. 8 lakhs and plus 16 5s are 80 into 100, 8,000 minus 32. So it's kind of, 1000 crore minus 100 crore will be 900 crore. 900 crore plus 2 crore. 902 crore minus 8 lakh. कितना होता है? यहाँ पे 4 मैंने किया क्या यार? 5C2. Okay, the second term. Third term is 5C2 10 and 2 square. This should be 4, not 2. This, okay, plus 4 crore. So then 1000 crore minus 100 crore is 900 crore. 900 plus 4, 904 crore minus 8 lakh. 904 crore minus 8 lakh means 903 crore 92 lakh. 8,000 minus 32. So this will turn out to be 903 crore 92 lakh and 79,000. 32 गया 100 में से तो 78. 68. Just check if I am correct. Unit, tens, 100, 10,000, lakh, 10 lakh, crore, 10 crore. It should be 903 crore. One of the zero was missing here. 903 crore, 92 lakh, and then 7,900 and 8,000 minus 32. 8,000 minus 32 is 7,900. Subtraction, I'll just write down for simplification. This was like your 900 crores. And when you add this, it will be not 900 crores and these three, 900 crores and then 4. Sorry. This is 904 crores. Correct? 1,000, 10,000. एक और zero. ये तीनों टर्म का 1,000 minus 100. 1,000 minus 100 is 900. 900 plus 4 crore is 904 crore. 904 crore, if you subtract 8 lakh, it will be 903 crore and 92 lakhs. 903 crore and 92 lakhs. And then 7,900. Okay, chalo, agla question. Which is larger, the first term or the second term? Now, very simply, you're going to just use the expansion. 1.01. How will I expand it? 1.01, the whole raised to after 1. 1, 2, 3, 4, 5, 6 zeros are there. All right. I can write it as 1 plus 0.01, the whole raised to 1, 2, 3, 4, 5, 6 zeros. If I expand it, I will get 1, 2, 3, 4, 5, 6. Which expansion will we use? The third formula. Can you see the third formula? 1 plus x raised to n formula. NC0, NC1x, NC2x square, like that. So NC1 into 0.01 plus 1, 2, 3, 4, 5, 6 NC2. पहले तो NC0 होगा ना, पहले तो NC0 होगा, फिर 1, 2, 3, 4, 5, 6 NC1, first term raised to this minus 1 and second term, which is your 0.01 raised to 1. And then remaining terms, remaining positive terms. Can you see what is NC0 in general? It is 1. NC0 in general is 1. And what is NC1? Is n. So this is 10 lakh C1. It will be 10 lakh into 0.01 plus some positive terms. Let me write this as some positive. This is 1 plus, shift the 2 zeros. Simply, you will shift the 2 zeros. What say, guys? And how much is that? 10,000. 1 plus 10,000. 2 zeros you will reduce plus some positive terms. Now 1 plus 10,000 is 10,001 plus some positive terms. Can you see 1.01 the whole raised to 10 lakh is already 10,001. That means 1.01 the whole raised to 10 lakh is already greater than 10,000. Proved. Proved. How do we prove? We just expand it. The first term is 1. Second term is 10 lakhs into 0.01. That becomes 10,000. 10,000 plus 1 and some more terms. So easily shown that this number is greater. Using binomial theorem, prove that 6 raised to n minus 5n is always leaves remainder when divided by 5. Now, how do we conclude that something leaves a remainder 1 or k in general? Alright, so when the number 6 raised to n minus 5n is equal to, when it is divided by 5, it is 25 times k plus 1. Then we can say that when this number is divided by 25, it will leave a remainder 1. When this number is divided by 25, it's a multiple of 25 and there is 1 extra left. That 1 is the remainder. So this is what we have to prove in general. PPT to prove that. And how should we do it? Let's start with 6 raised to n. Isn't it 1 plus 5 the whole raised to n? And use the third formula 1 plus x the whole raised to n. It's nc0 plus nc1 5 raised to 1, nc2 5 raised to 2, nc3 5 raised to 3 and so on. nc0 is 1, nc1 will be your n5, that means 5n, plus nc2 5 square plus nc3 5 cube plus nc4 5 raised to 4. Okay, take this 5 raised to n on the left side. 6 raised to n minus 5n is equal to 1 plus. From all the remaining terms, you can take 5 square common. You will have nc2 plus nc3 5 plus nc4 5 square and so on. Let me call this entire bracket as something like k. What is this k? K is this entire bracket. Proved. Therefore, 6 raised to n when divided, 6 raised to n minus 5n when divided by 25 leaves remainder 1. Leaves the remainder always. 1 is left. Okay. Got it? Question? So, NCERT question is what is noted. Let's move to the next part, which is general term and middle term. Middle term कहाँ गुल हो गया इसका? One minute. Middle term इधर है 2.3, 2.1. General term and let us check only the formulas of both of them. Now it's brilliant that we can find out any term, any random term in the expansion. How is that? If you know x plus y raised to n is equal to nc0, nc1, nc2, nc3 and so on. Can you see this is nothing but your first term? For first term this is 0. For second term it is 1. For third term this is 2. For fourth term this is 3. So in general, if I want t of r plus 1th term, I'll have the formula NCR x raised to n minus r y raised to r. That's your formula for general term in the expansion of x plus y raised to n. Right? Because this is always greater. For first term, this should be 0. Second term, this should be 1. So for r plus 1th term, this should be r. That's the formula for general term. Clear? Loud? Amazing. Now one more formula that comes very, very handy with this is NCR upon NCR minus 1. This formula will be used a lot of time in the question. The formula is NCR upon NCR minus 1 will be equal to n minus r minus 1. You subtract these two and put your, where is this r comes? What I mean to say is if you have NC7 upon NC6, the answer will be n minus 6 upon 7, n minus 6 upon 7. Can you all see and understand this? बल्ले बल्ले बस फिर इसको ध्यान रखना. And what is middle term? Now middle term, there are two types, when n is odd number and when n is even number. That means in the expansion of x plus y raised to n, if n is an even number, total number of terms will be odd. You can get middle term, there will be only one middle term and it is given by the formula n by 2 plus 1. N by 2 plus 1th term. What is middle term? It is n by 2 plus 1. But if n is odd, then on expansion you will have even number of terms. And there will be two middle terms. There will be two middle terms. One will be n plus 1 by 2 and the other will be n plus 3 by 2th term. These two terms will be your middle term. Remember it very well. That's your formula. Let's do the questions on them and finish this chapter. Find A if 17th and 18th terms are equal. So, how do you find a 17th term? Very easy. In the formula 50C, if this is 17 here, it should be one term. First term is 2 raised to 50 minus 16 will be your 34. And second term, A raised to. Whereas 18th term will be 50C. If this is 18 here, 17. First term raised to 50 minus 17, 33 into second term raised to this 7. We have been said that they are equal. 17th and 18th term are equal. Therefore, 50C is 16, 2 raised to 34, A raised to 16 is equal to 50C 70, 2 raised to 33, A raised to 50C 16, or if I take this 50C 16 on the other side, 2 raised to 34, A raised to 16 upon 2 raised to 33, A raised to 70 is equal to 50C 17 upon C 16. This cuts. So we are left with 2 by A is equal to, and remember this NCR upon NCN minus R is, we will do 50 minus 16, that's 34 upon 17. How much is this? 2 by A is equal to 17 ones are 17 twos are 2. And the value of A comes out to be equal to 1. I use that formula. Wonderful. Next question. In the binomial expansion of A minus B the whole raised to n greater than or equal to 5, the sum of 5th and 6th term is 0, then A by B is equal to which of the option? You all can pause and solve it, answer me as well. Let me show it for you. 5th term will be equal to NC4, first term raised to n minus 4 and second term raised to 4. Now this is 4 even, that's why a plus sign. And 6th term will be NC5, first term raised to n minus 5, second term raised to 5. Can you see odd and odd have minus? It's an expansion. They have said the sum of 5th and 6th is 0. When I add the two terms, NC4, A raised to n minus 4, B raised to 4 and minus NC5, A raised to n minus 5, B raised to 5, this should be 0. Simplify. NC4, A raised to n minus 4, B raised to 4 is equal to NC5, A raised to n minus A raised to n minus 4, B raised to 4 upon, bringing those coefficients here, A raised to n minus 5, B raised to 5 is equal to NC5 upon NC4. Once again use that formula. NCR upon NCN minus R is equal to n minus 4 upon this bigger number 5. And here what all things are getting cancelled? This B entirely goes off. One B is left in denominator. N minus 4, n minus 5, which is bigger? N minus 4 is bigger. So n minus 5 will go and one of the A is left numerator. A by B is equal to n minus 4 upon 5. Option B barobar hai. Right, boss? Very good, excellent, superb. Show that the middle term in the expansion is this, where n is a positive integer. It's an NCERT question, but an important one. Middle term you have to show. Now 2n is an odd number or even number? It's an even number. So how many middle term it will have? One middle term. And what is the middle term? For finding the middle term, we divide the number with 2 and add 1. So n plus 1 term is nothing but your middle term. Middle term is what? N plus 1. So finding the n plus 1th term, formula will be in this expansion 2nc 1 less, and first term raised to anything is same, x raised to. Look carefully what we have to prove. We need x raised to n, and this entire thing has to be solved and found. 2ncn, if I apply the formula, will be 2n factorial upon n factorial into 2n minus n the factorial into x raised. This will be 2n minus 1, 2n minus 2, so on till, let me write 2-3 more terms, 2n minus 3, 2n minus 4, so on till 4, 3, 2, 1, right? It will go on till 1 all the way. There is x raised to n outside. This is n factorial, and 2n minus n is again n factorial. From all this, what I'm doing is check karna. Writing the even terms, odd terms first. 2n minus 1, 2n minus 3, 2n minus 5, 2n minus 5, and so on in one bracket. And this will be like 3, 1, 5, 3, 1. And all the even numbers. From all the even numbers like 2n, 2n minus 2, 2n minus 4, I'm taking 2 raised to n times common. I'm taking 2 common from each of the term. So I'll get n minus 1, n minus 2, n minus 3, up till 1, divided by n factorial, and there is also x raised. Check out this. What is this? n minus 1, n minus 2, n minus 3. This is nothing but your n factorial. So one of the n factorial goes. The other n factorial is needed. X raised to n is needed. And what about this? The first bracket. कुछ नहीं यार, सेम ही चीज तो है. 135 dot. This should be 2 raised to n, by the way, huh? And you just write this first term in a reverse manner, 135 dot 2n minus 1, and then in the second you have 2 raised to n, x raised to n, the denominator, n. Proved. Check, pause, understand. Check, pause, understand. Good. Next question, last question, I believe. What is middle term in the expansion? Now, middle term will be, if it's an even number, divide by 2 plus 1. 12 by 2, 6 plus 1. 7th term is what they are asking us. So, for 7th term, formula will be 12c, 1 less. First term raised to 12 minus 6, and second term raised to 6. I've taken already minus sign into consideration, so no need of putting a plus minus here. Or if you can understand, this is even, so that will be plus. So this will be plus. 12C6 is nothing but, if you look at the options, it is like this. C 12, 6. Are none of the options has 6. How is that possible? These two options, this is typo. These two options have 6. So already A and C are out of question for me. A and C are not the answer. X raised to 6, y raised to root, if I take 6 by 2, 3 upon 3 raised to 6 into 3 raised to 6 upon y raised to 6, x raised to 6, and this square root, 6 by 2 will be 3. This is C 12, 6. 3 raised to 6 cancels, x raised to 3 and y raised to. Option B or C, both are again, they have given to be same, which is again a typing mistake, should not be like this. I'll just correct it. Let's put one of the options like this. Now B or D, D is the answer. X positive, Y negative. In B, X negative, Y positive. So anyways, if you consider the earlier thing, don't change. B and D both same. That's it for this particular chapter. Did you enjoy? Did you understand? पक्का बोलो, सच्ची बोलो, एकदम से हार्ट बनाने की प्रैक्टिस हमारी जारी रहेगी हर क्लास में. मिलते हैं अगले लेक्चर में, विच इज सीक्वेंस एंड सीरीज. थैंक यू सो मच. टेक केयर. बाय बाय.